All right, I think we're going to get started. Good afternoon. I'm going to talk about manage your heterogeneous environments with PowerShell Core, and I'm going to explain in a bit what I mean by heterogeneous in this context. First, if you don't know who I am, I'm Steve Lee. I'm the Principal Engineer Manager for PowerShell team. So I own Windows PowerShell, PowerShell Core 6, of course, Script Analyzer, VS Code, PowerShell Extension, Editor Services. What else do I own? Some other projects. And yeah, so that's pretty much all I am here. So starting with Sad Joey, what this is about is I'm expecting everyone here is already familiar with Windows PowerShell. And some of you, if not all of you, also now need to start managing Linux systems. This is kind of part of Jeffrey's keynote this morning, which is, digital transformation. You're going to be doing more, leveraging your existing skills. How can you do that where you're an experienced Windows admin and start managing non-Windows systems? So I'm going to kind of go quickly through this first set of slides because it kind of just recaps what Jeffrey, I'm assuming everyone here saw Jeffrey's keynote anyways. So I'm not going to go into a lot of detail here, but it's the same kind of content. Basically, 2018, PowerShell has not been more important. It's not about the cloud, it's about digital transformation. Digital transformation is really about enabling you to create more bandwidth so you can spend that bandwidth on what's actually business critical. And one way to do that is through automation. And of course, automation, PowerShell. So again, the idea generally is from anywhere to anywhere. And PowerShell Core 6 specifically is supported on most everything that people care about. So first, just a quick show of hands, like how many people here actually use PowerShell Core 6 or have used it? And how many people, keep your hands up, use it on a regular basis? All right, so hopefully next year it just stays up. But for those who are not as familiar with PowerShell Core 6, basically, and Jeffrey covered a bit about this. We started this project probably about 2.5 years ago now. We open sourced it, or we announced it back in August 2017, I think. And it took a while because there's a lot of challenges getting it working well on a non-Windows environment. There's a lot of expectations in the code base about being on Windows. So we cleaned all that up. We GA'd our first 6.0 release January this year. We had a 6.1 release September 13th. We just had a 6.2 preview 1 release out today. So definitely one of the things about open source is we can go much faster than on Windows. In Windows, we kind of lock with the Windows timeline, which these days is actually much faster than it used to be. But we can actually address customer issues much, much quicker. And a link to some of the announcements. So to quickly just go over this, the main changes here with PowerShell Core 6 is really getting into ubiquity. So one of the things we do realize is that people are more likely to use it if it's there. So there is this kind of elephant in the room, which is it's not inbox in Windows. I think I kind of cover it later on. It's something that will happen eventually. I don't have like a date of when that will happen, but as Jeffrey said, Windows PowerShell 5.1, it's completed supported. You should continue to use it. I would like you to start using PowerShell Core 6 in addition. I'm going to talk about some of the tips and tricks to do that. But certainly that's one of the things that we got to do is get it in Windows eventually. It is available in a lot of different CI systems. Of course, Azure DevOps Pipelines has it. PowerShell Core 6, even on Windows. You can actually have a choice on the Windows instances if using either Windows PowerShell or PowerShell Core 6. On their Linux and Mac OS instances, you can just use PowerShell Core 6. Adverse CI also supports it. AWS Lambda supports PowerShell Core 6. I think they announced it about a month ago, and I think Kenneth has probably a demo about it in a session following mine in a different room. I talked about the open source stuff. Community, let me just talk about briefly about that. Again, one of the things that Jeffrey highlighted is about just actually over 50% of our pull requests come from the community. Now, it's not necessarily apples to apples because a lot of the smaller, low-hanging fruit that my team wouldn't take as a priority get done by the community, which is awesome. But certainly, more recently, a lot of very interesting and complex changes have been coming from the community, like performance changes, like PowerCode. Stefan has been doing some great stuff there. Of course, Ilya. I'm not going to name everybody, but there's a bunch of well-known contributors that do a lot more of the feature work, which is pretty awesome. So definitely stuff coming in that my team or my organization may not take as the highest priority. Just a quick reminder, though, that we do have a monthly community call. It's the third Thursday of every month, which would have been yesterday. Today's Friday? Yeah. So we canceled that because most of the important people are here. Joey's back in Redmond, but that was canceled. But anyways, All right, so then let's quickly talk about Windows PowerShell. Again, it's done, meaning that we support it. So if there's any major security issues or major customer blockers, we will fix those. And we have made fixes in 5.1. We have no plan to rev the version, okay? So, and we also have no plan to take the changes that we've made in Windows 10 and Server 2019 in 5.1.x down level. There's no release vehicle for WMFs at this point in time, so you will not get it down level. So the other key things here, and I'm going to go over some of this in terms of demos, which is cross-platform, side-by-side. Again, I agree with Jeffrey. We don't talk about this enough, and I will have a demo about that. All new features. There's a ton of new features in 6 and newer that I'm going to show off. The other important thing is remoting. I'll cover that as well. So first, before I go into demos, and this is the bulk of my presentation, is all these demos. Are there any questions about PowerShell Core 6, Windows PowerShell up until now? If not, I'm going to kind of jump right in. So I have kind of like 3 sections of demos. First one is really heterogeneous. If you're in a mixed environment where you have just Windows and you have existing Windows PowerShell, and you want to start using PowerShell Core 6. So the first set of demos is really how to compare these two things. And if I can find my mouse. So I put all my demo scripts up on GitHub, so they're all GIFs under my account. So let me just bring that up real quick. Yes, skip that. So you can also, if you just go to GitHub, you can look at all my GIFs. I have a couple other things as well. And I'm just going to copy this into, oh, come on. Work. All right, I'm going to do it the other way. I don't want you guys to figure out the timing of my key presses. Yes, connect. All right, I need to go to a Windows box, which is why I'm RDPing to my office machine back in Redmond to do this demo. Good, it's not doing an update. That would be like the worst thing. All right, get rid of this guy. So I'm going to just paste the script I had there. I'm going to change this to PowerShell. That way you can see the syntax highlighting. Well, at least it's not updating me right now.
Yeah, no.
All right, so let me just go to the top of this. So the first thing I want to show, again, this was mentioned by Jeffrey, is like one of the benefits of PowerShell Core 6 is completely side-by-side with Windows PowerShell. That means that you can use the two of them together and one won't stomp on top of the other one. Like in the past, if you upgraded from WMF4 to WMF5, WMF5.1, it always updated your existing Windows PowerShell, and we may have inadvertently had bugs that caused regressions. So there was always a risk of deploying it across your enterprise. In the case of PowerShell Core 6, you can keep whatever Windows PowerShell you're currently using, and you can also install it side by side, and you don't even have to be admin, which may sound scary, but you know, there's no known attack vectors within PowerShell. It's running under the context of your user anyways. So let me just do this first one. So I'm going to do this within my existing PowerShell course. Get out of here. So all I'm doing here is I am downloading the package from GitHub. This will take a little bit of time. I unblock it because obviously it's going to mark this coming from the internet. And then I'm going to expand it. So again, this is running as a non-elevated user. And once this finishes, it's not going to take too long, then I'll run the one I just downloaded. Come on. Work. All right, so let's go into this folder. And there we go, right? I didn't have to be admin. I got my copy of, in this case, I have the same copy because I have the same version, but I can do the rest of my demo from here. So the first thing I want to show, again, this was mentioned, is we made an explicit decision to rename the executable for PowerShell Core 6 to PWSH. This means that when you're running the same script in either environment, it's predictable, right? So here, let me just paste that. Sorry, I keep hitting the Windows key because of Mac keyboard differences. Oh, we had this other problem with the font. where's my consoles? This didn't happen before. All right. Let's see. So what this is showing is that, so I have a very simple script. It's just going to output the PS version. And I'm explicitly calling it from PowerShell and also PWSH. And you kind of see the first time it should be 5.1 as expected. Second time is 6.1. And if you were to just run it from like a, if you just, this should just work, I think. What is this demo PS1? Then, oh, in this case, it's going to bring up Notepad. But if you had bound it to either PowerShell or PWSH, it would start it from there, right? So the idea here is that you would know exactly which one you're using. There's no unpredictability here. There's been a ton of performance improvements. The first one I want to show is thread jobs. So this is something we added in PowerShell Core 6, so it's just there, but it's actually published on a gallery as well. So you can actually use it in Windows PowerShell. The basic idea here is that if you want to do concurrent script blocks in PowerShell today, you probably use start job. Start job is actually creating a new instance of PowerShell. So there's a lot of overhead of creating a new process. But instead, if you were to do exactly the same thing, and all I'm doing here is just starting 10 instances where I do a 1+1, and I wait for all of them to complete. You can kind of see like the first one took about 5.5 seconds. The last one took less than a second. You know, the main difference is we're using threads instead of processes. So if you do require process isolation, then continue start job. If you don't need that and you just want to run stuff concurrently, thread job will get you much better performance. All right, this is a good demo here. So one of the changes from the community was that really impacted and helped with performance is write progress. So here I'm going to re-download PowerShell Core 6.1, start it in Windows PowerShell. You can kind of see it running. I'm going to do the same thing now in PowerShell Core 6. And it's done, right? And Windows PowerShell is still downloading. And in fact, it's probably going to take a while. There's only about 7 megabytes. It's like a 56 meg package. The basic idea here is that one of the issues that was in Windows PowerShell is that write progress was being updated every time it was requested. So the web command list was basically downloading a couple bytes and then saying update the progress. And a lot of time was actually spent updating the console versus actually downloading. So you can kind of see, like, I didn't even let this finish because it's going to take forever. There's a huge performance difference. So anything that uses write progress is actually going to see that impact. So even like expand archive is another case where it could take a long time in Windows PowerShell. It's actually much faster in PowerShell Core 6. All right, so now let's see a couple of, here is an example of a benefit from just being on .NET Core 2.1. First, I'm going to download this script. Again, this is on a gist. Basically, I can kind of show if you're interested. I think it should show up here. I took a reference implementation of a base64 encoding and decoding algorithm and wrote it as pure PowerShell script. I don't call any commandlets here. I try not to call any .NET APIs other than string builder. And to test this, because this kind of runs pretty fast, is I take the script itself, I make it 1,000 times bigger, and then I just basically convert it to base64. I convert from it. I just make sure it works. And here, if I go back, so if I run it here first, again, this is really just testing the CLR here. About 3.5 seconds. I want to run the same thing in Windows PowerShell. And you should already feel like it's been more, about like 5 seconds, so about 50% performance difference just on pure PowerShell script engine performance. This one came from, I think Stefan, known as PowerCode, did this one. This is improvements to group object. Again, this is just generating 1,000 random numbers 10,000 times and grouping them. If I do the same thing in Windows PowerShell, again, you should see a pretty decent performance delta here, so almost 2x, depending on how you do the math. Sort object, another commonly used commandlet that got perf improvement treatment. So again, about 1.6 seconds. And then Windows PowerShell 2.8. So again, these are specific improvements made in those commandlets. if you do a lot of CSV, comma separated file processing, where's my mouse? There was also improvements made there to work with large files. So this first, all I'm really doing here is just generating a large CSV file. So I'm just getting all the process on the system, and I'm basically kind of exponentially making it 5 times bigger, or power to 5. So this will take a little bit of time. Yeah. Mm-hmm. So the question is, so I had some demos on showing PowerShell Core 6 in general being faster than Windows PowerShell. Like, what made it faster is kind of like the question. So it's really, again, like there's 3 things that happen. One is .NET Core, which was a kind of rewrite of .NET quote-unquote framework, although it's .NET Core. So they had a lot of opportunity to make improvements in the CLR itself, the Common Language Runtime. So those benefits we get automatically, right? The other thing is we have made some small improvements here and there in the engine itself. And then there's also been improvements in the actual commandlets themselves, right? So all these 3 things mean that in general, you're going to get performance improvements. There is one, I'll admit there's one performance gap that is known, which is the startup time. It is actually slightly slower right now to start up PowerShell Core 6 than it is to start Windows PowerShell. It's something that we're working with the .NET Core team to figure out how to solve that. So here, but in general, I think with the changes in .NET Core, you should see some level of a performance improvement. And then if there are any particular commandlets that are slow, just open up issues, and we can take a look to see if there's some obvious fixes we can do there. This is just showing that this is a 7,600 line CSV file. And again, so this one has specific changes to the import CSV commandlet to show the performance difference. So again, it's about a 2x difference, right? So again, in general, if you're working with small files, you're probably not going to notice a difference. But if you're working with large files, this can, or if you're doing it a lot of times like in CI or whatever, you can certainly see this improvement over time. So another kind of like a feature-esque thing that we did is classically, in fact, I'll show it here first. Like if you wanted to update help, again, neither of these windows are elevated. This will fail. Because it says, hey, I can't write to the shared help folder. You have to be an admin to do it, right? So you have to be elevated to update help. So one of the things we did in PowerShell Core 6 is, hey, why do you have to be admin to update help? So help just got updated. I'm not an admin. You can still update it as admin for the system, but if you run it as non-elevated, you can update it for yourself. Here's another improvement I want to show real quick, which is with Windows PowerShell, you can't see the parent process of a process. So there was a change. Again, this was contributed by a community, which is you can see they added additional property to the system diagnostics process instance to show the parent processes of each of the processes. So you can now kind of map out a tree of the processes. So one of the big scenarios we really want to target for PowerShell Core 6.0 early on was really about cloud. How do you interact with like AWS, Azure? A lot of it's with REST APIs. So here, if you use the web commands before, let me just make sure I understand. It's like there's 2 primary web commands. There's invoke REST method and invoke web request. The main difference between those 2 is that if you do invoke REST method, you're going to get back an object. Well, you get back an object that represents the body of the response. If you do invoke web request, you'll get back an object that represents the web response all up. So you have to parse out the body, the headers, and all that stuff yourself. So if you want to do more parsing, the web request makes sense. If you just want to call this REST API and get back the JSON body, then REST method makes more sense. Now, one of the downsides with calling REST method is you don't get all the other metadata, right? You don't get the headers and all that. So one of the changes was to add this response headers variable. So now you can actually get it. So here, it stores it in a variable named h, so I can just access h. You can kind of see I'm calling the GitHub API. This is on issues. And you can see like there's actually a bunch of important metadata that I should actually care about if I'm going to proceed to do additional calls to this API. In fact, for the next demo, it's really about this link header. So basically, if you're calling a REST API and there's like thousands of results, what they don't want to do is actually return a whole bunch of results to you in one payload. So there's this whole concept of pagination, so you can get different pages of results. So one of the changes that was made was that you can actually have the web commandlet automatically follow this link and get the next set of results for you. Otherwise, you would have to parse out this header, grab this URL, and do you have to do like a loop to get these results. So I'm going to do, did I not? Oh, yes, I think. So here, if I just look at a count, then it gave me 1 page of 30 issues. So in this second step, I'm going to say follow the rel links automatically, and I want to follow up to 3. So you can specify how many you want to follow. So one thing to keep in mind, though, is you may expect this to be 90, but it's actually going to be 3, because it's actually going to be 3 collections of 30. So using a little trick in PowerShell to automatically unwrap collections, because I know each of these instances within the collection has a title property, I could actually do this and get all 90 of them. So this would be equivalent to something like this. Let me go back here, and I'll explain what I'm doing once I correct this little mistake here. Where's my cursor? Yeah. So basically, excuse all my shorthand, but I prefer the percent assigned to for each object. I'm just passing the J, which is a collection of collections, to the pipeline that's going to unwrap all these collections, and I'm just going to output each object. And then now that I have them all, I can get a count. But if you just want to count, this is much easier, shorthand, the title trick. So obviously, if you call a lot of REST APIs, not all of them allow you to call them anonymously. Like sometimes you have to be authenticated. So here, I already have a token local on my box, personal access token I created on github.com. And so one of the changes, again, this came from the community, Mark Krause, who now works at LinkedIn. So I don't know if he's technically community anymore. But basically, in the past, if you wanted to make an OAuth call, you would actually have to craft the header yourself, and the header requires you to have a specific format. You have to base64 encode your token. It was a little bit complex. You also had to worry about stuff like timestamps and all this other stuff. But it's all taken care of for you, as long as you use OAuth and you pass in the token, and it just works. So I'll just do this. Again, I got my 30. So along with calling REST APIs, the other counterpart to that is JSON. So we also had some improvements here. So one of the things I'll show in Windows PowerShell first is just simply formatting. Like this is the PS readline module converted to JSON. You kind of see it's a little bit hard to read because there's just a ton of white space. Basically instead of using tabs, we're using spaces, and it's just much easier to read because it's not all split across the lines. Very small change, but makes it a much better experience. Another thing is, which I'll do here first, if you are familiar with JSON, you can actually have a property that is an empty string for the key name, the property name. So if you do this in Windows PowerShell, it says, hey, I can't do that because name is empty. I can't do anything about it. Now, in PowerShell Core 6, you're also going to get an error. But we added this, or actually community, I think, I forget who did it, but added a as hash table. So the key thing here, I can just add the as hash table, is that a PowerShell custom object, which is what comes out of the convert from JSON, doesn't support a property that's an empty string, a property name that's an empty string. But a hash table supports it. So now this works perfectly fine. So it's a little bit inconvenient. We have an issue that we're trying to evaluate if there's if it's a impactful breaking change if we support empty strings for a PS custom object, and that would remove the need to have this as hash table. So again, in Windows PowerShell, we were using a .NET JSON serializer. So here, again, this is the square brackets represent an array. This is a equals test. And one of the problems you had is because of all the automatic unwrapping that pipeline does, you can kind of see the stuff that I put in after I convert it from JSON back to JSON. This is not the same as what I have here. And if you keep, actually, if you do it again, it may work out okay. But one of the changes was, hey, it doesn't make sense. Even though the format looks different, it's actually the same JSON. Like it's repeatability and it has symmetry. So it makes a lot more sense. Okay, this one's good. So one of the things we also took into PowerShell Core 6, and actually we checked into Windows 10 October 2018 update as well, is PS Readline 2.0. One of the changes I like is really the menu complete. So if you do on Windows Control Space, then you get this nice thing that shows you all the different options rather than just tabbing through all the different ones. Whoops. No, what happened? Hold on. Okay. And this also works with .NET types as well. So here, whoops, I didn't mean to do that. I want to do menu complete. So again, makes it much easier as you're writing your scripts. Okay. So another cool thing is if you're interactive, using interactive console, then navigating back to where you were before, the shorthand, you can do, if you do push location, pop location, you get the same equivalent, but you'd have to push it first. Just CD minus, then you'll go back to where you were before. The last thing I want to show here is Markdown. So this was mentioned in the keynote. Again, this is really for the interactive console. This is for the README that exists in our PowerShell repo. Basically, we're now, because Windows Console supports ZT100 escape codes, of course this also works on Linux and Mac OS, we're able to actually, and there are obviously some issues we got to resolve in terms of tables and whatnot, so let me just scroll that off the screen. But you can kind of see like it certainly improves the readability, and the colors are customizable, and we want to use a similar kind of rendering for help going forward. In fact, on some terminals, you can actually make some of these things clickable hyperlinks. Windows 10 currently doesn't support that, but hopefully they'll support them in the future. So that way you can actually follow help links to other help and stuff like that. So let me quickly go back here. All right, so that was the first part. I have two other parts coming. How am I doing on time? What? I still have a lot more. Okay, I'm going to have to go a little bit faster, sorry. Okay, so the main takeaways here is if you're not using PowerShell Core 6, you should use it, and you can use it side by side safely within your environment. One of the reasons, but not the only, those are two big reasons really to use PowerShell Core 6 over Windows PowerShell is really the performance improvements. You'll see that right away. And also, if you're using it in the web command list, JSON commands, and all the other commands that we've made improvements, there's just been a ton of improvements moving forward on PowerShell Core 6 that we're not taking back to Windows PowerShell. Oh, all right. Interactive console improvements, yes. And we're going to continue to make improvements in PS Readline. So I am committed to having some of the resources on my team helping Jason Shirk on that project. All right, so the next section is, so now you're on board with PowerShell Core 6. You think it's great, but you still, again, have to worry about Windows PowerShell. Maybe for some reasons you can't deploy it. How do you write scripts that are agnostic to the version of PowerShell you're using? So I'm going to go to a different gist here. And we go back to my Windows machine. New file. All right, let's paste that. All right, so the first thing you should be aware of is that we have this PS edition. So again, if you just look at PS version table on both of these, then you can see like on Windows PowerShell, it's called desktop. So even on Windows Server 2019, it's going to be called desktop. And yes, we kind of regret that, but it is what it is now. And on Core, it's going to be called Core. So even on Nano Server, the PowerShell Core 5 would be called Core, but no one, as far as I know, uses that. But the thing here is if you want to have the same script work in both environments, then you should check the PS edition. That's the way to do it. So here, I'm going to run the same script on both. Again, it's able to recognize it because basically all I have to do is check if PS edition is equal to Core, then on Windows, I know I'm running, actually even on non-Windows, I know I'm running PowerShell Core. Otherwise, I'm running Windows PowerShell. And then if you have specific logic that you need to have for Windows PowerShell versus PowerShell Core, you can do that within the script blocks. One of the changes we made intentionally that's breaking is to get content. So I'll do it here first. So if you wanted the output of a file as byte stream, you would use -encoding byte. And this doesn't work in PowerShell Core 6 anymore. Basically what happened is that when we're reviewing some of these commandlets, encoding here in the Windows PowerShell commandlet was basically a validate set. So it was very limited to whatever was decided to support at that point in time. And decided to add byte as an encoding, and it's technically not an encoding. Like encoding should be a U2F8, Unicode, stuff like that, ASCII. And what we wanted to do in PowerShell Core 6 is actually use the actual encoding type. And the benefit there is that any commandlets that require encoding can pass that directly to the .NET API. So if there's new encoding types, you automatically get it for free, right? So instead, we introduced this as byte stream switch for the equivalent behavior. So now the problem is, hey, I got the same script I want to run on both PowerShell Core 6 and Windows PowerShell, but they have different parameters. How do I handle that? So the idea here is I recommend just using splatting. So splatting allows you to define a hash table, and at runtime, PowerShell figures out which keys map to what parameters, and the values of those keys map to the parameter values. So here, I'll just run it real quick now. I'll explain the script real quick. Again, you get, whoops. Oh, that worked anyways. It's running it twice because I didn't finish it right. So again, based on what I said before, you check the PS addition. So in this case, if you can see my mouse on the right side, if it's core, then I know I need to add this as byte stream true. So this will make a switch that's on. Otherwise, I'm going to use the legacy encoding byte parameter. And using this syntax with the @ instead of $, it turns it into parameters that fill out the commandlet. So that way, for known breaking changes, you can use this as a way to be able to support both Windows PowerShell and PowerShell Core 6. Again, I think Jeffrey showed this demo already, so I'm not going to go into too much detail here. But a lot of the time that we spent in the 6.1 time frame was not necessarily in PowerShell Core 6.1, but in Windows, working with partners and making changes ourselves to make more of the modules compatible. I don't have as many available because I don't install as many roles as Jeffrey did for his demo. But one of the ones I want to show is actually the Active Directory module. So we worked with the AD team to get this working. And there you go. So now you get the SID for my computer. I guess it's recorded, but you have to be on CorpNet. I'm going to have to like re-provision my machine now. The Apex module was also previously not working in PowerShell Core 6, and of course now you can see all the Apex packages. So one thing I want to kind of show here is, so there's this thing called skip addition check. So before let's see, I might just scroll up first because I don't want to run it again. So here on the top window, if I can get back to where it was, so we have this PS addition property, and basically you can kind of ignore, this is where it gets a little bit confusing with going into a ton of detail. If you're interested, you can talk to me afterwards, I explain. But we added like looking in the Windows System32 Windows PowerShell v1 modules folder. And if it's marked as core or has core in it, then it means that we've done some validation or our partners did some validation and we believe it works in PowerShell Core 6. So those will automatically show up. Now there are a set of modules. So here if I do the skip addition check, it'll still work. It's actually going to show all of them, even the ones like here, for example, MSDTC is not, I don't remember exactly the details of why this one doesn't work, but it may be some specific technical reason why it didn't work. So we left it as desktop, meaning Windows PowerShell only. That way you don't get a bad experience trying to import this module that shows up and it doesn't work. If you do have issues with any of the ones that are marked as core in Windows, go to this repo. We're using this repo to track issues. There's only 3 right now. So I'm hoping more people participate. But again, if you open up issues there, I will work with those Windows partner teams because they may not be on Twitter or GitHub, and I'll track someone down and we'll get to the bottom of it. We'll get it fixed in a new version of Windows. Yes?
Like third-party modules, is it the third-party creator should fix that, or this is for you?
For third parties, like even stuff on the gallery, then it's really the responsibility of the third party. So one thing I want to make clear though is that the skip addition check is only applicable, only necessary for modules that are in the System32 path, right? So third parties probably install under program files and will show that information, but it's only informational. We don't block it because we just don't know, right? On the Windows side, we have more control because we work directly with the Windows teams, so we make that call. So now, I'll show you again the PKI module is one that we know doesn't work today. If you do the list of all, it doesn't show up. If I do the skip edition check, then it is there. It's available. It's in Windows, but hey, it's only marked as desktop. So if I want to forcibly try to use this, I can always do a skip edition check. And hey, it looks like it imported. Let me try to now run one of the commandlets in this thing. So PKI is the public key infrastructure, I think is what it stands for. So you can ignore all the text. This is just one of the samples from help, I think. But basically, hey, it actually didn't work because when it tried to initialize one of the types, it failed, and it probably failed for, actually in this case, I actually know why it failed, because the PK module uses managed C++, which is not supported in .NET Core. So the question is, how do we use this? Well, we have this Windows compatibility module thing. I'm going to skip the install because I already have it installed. But kind of like what Jeffrey showed in his demo, is instead of import module, we do an import win module PKI. We use implicit remoting, which is an existing feature in Windows PowerShell. And now if I go, actually I want to do it this way because I don't want this cert. This cert will get created. I don't want it hanging around my system, so I'm going to just remove it because it's a bogus cert anyways. It's just see, it has fake information. Basically now, this is actually going to work because I'm calling this module. It's actually calling back into Windows PowerShell to do the work, and then the results get returned back to PowerShell Core. So you can kind of see, yeah, I created this thing. In my last night, I got it off my system because I don't want to have these bogus certs hanging around. There's actually one last case here, which is there are certain commandlets that we actually had to remove out of the core commandlet modules, like management, utility, core, primarily because they're using undocumented APIs. And when you're in Windows, that's OK. When you're out of Windows, like open source, that's not OK. So we had to remove. So stuff like clipboard is one. So if I do get clipboard, hey, sorry, it doesn't exist. If I do get clipboard here, yeah, this is what I had in my clipboard. So again, I'm going to import this using an import win module. Then what it's going to do is going to determine, hey, this is a module that already exists, but there's a bunch of commandlets that aren't in the one that's part of PowerShell Core 6. So I can actually use those again now. So again, I'll just type this real quick. Now set clipboard will work, and get clipboard will also work, right? Oh, there's a bug. Boo. The demo gods don't like me. All right, ignore that. It worked earlier. This is how you know it's live, it's real, because things don't work perfectly. Yeah, anyways. Let me go back to, I have one last section, which is going to be more about Linux. So the main takeaways from this last section, again, if you want to write scripts that work, the same script that works against Windows PowerShell and PowerShell Core 6, you got to leverage the PS Edition to make sure which, like in many cases, you probably don't even have to worry about it. But if you are doing something that you know is different between Windows PowerShell and PowerShell Core 6, check the PS Edition and have different logic in your script. You can use, we have a much more higher compatibility with the inbox modules. And for those that don't work, use the Windows compatibility module that's on the PowerShell gallery. All right, so for my last section, I'll just do a quick check. This ends at 4. All right, where's my mouse? Can't find my mouse. There it is. All right, my last gist of demos here. I'm going to do this for my Mac. Copy this, go here, paste that, change this to PowerShell. All right, so this last section is really about Windows versus non-Windows. And I'm trying to figure out, given the time I have, what I want to skip. Well, let's see how far we go. So first thing is, one of the changes we had in PowerShell Core 6 is you can use SSH as your transport for remoting. So in Windows PowerShell, you can only use WSPAN, which is WinRM. So I want to kind of quickly show that I want to make sure everyone understands the difference between SSH remoting and PowerShell remoting over SSH, because I don't think it's always clear for people. So here, I'm going to just use the integrated terminal. I'm doing pure SSH. There's no PowerShell involved yet. And I'm going to do my domain account to my Office machine. So I'm remoting from my Mac here to my Windows desktop that's sitting in Redmond. And so you can kind of see, like if I do PS version table, this will fail because it actually dropped me into CMD. But I can start PowerShell within here, and this all works fine. In fact, PS VLAN works. So again, this is just pure SSH. So what this means is it's just pure text, right? So you're not getting objects over the pipeline. However, I should get exit again, so I can do enter PS session, office-username, Microsoft.com. Now, by the way, I should mention the reason you don't see me typing in a password because I have public key auth already set up. It's just much more convenient. You should technically have a key for your public key, but for demo purposes, I don't do that. Like a pin. All right, so you can kind of see now I'm dropped into PowerShell. And in fact, I should have did a new PS session instead of, let me do that real quick. So the main difference here again is rather than having a text-based remoting, I can do invoke command. Oh, dang it, I should have done this way. This equals get PS session ID 2 command session. Let's do PS version table. So now this is going over SSH. You can see like this is using it's returning Windows. I'm on a Mac, so obviously it did the remoting thing. It's returning an object. If I have time, I'll get to the SSH deconfig thing. I don't know if I'm going to have time to get to that. Here, I'm going to show that from my Mac, and you can also do this from Linux, I can remote to Office 365. So let me just copy all of this. So again, I'm going to use my, see if I can type it right. Oh. All right. No, I think it needs the other format. Did I type it right? Okay. This is the downside of having a long password. All right. It's taken a while, so it means it's working. All right, so now I can import that session. Oh, PS session. So now I am connected from my MacBook up to Office 365, and I can manage my mailbox once I get all the commandlets from the cloud. And you can kind of see there's a large number, it's like 127 or so commandlets. All right, this is where it's creating a module on my local machine that's a proxy to the cloud. It actually looks like a large number of commandlets. Like over 400. And I can just get my mailbox. Again, when I'm running this locally, it's actually calling the proxy commandlet that calls up in Office 365. I'm going to skip this for now. It's not as interesting. We can, if there's an interest, we can talk about it offline. I'm going to probably run out of time here. But basically, if you want to do WSMAN-based remoting from a non-Windows box to a Windows machine, you can do it. There are a bunch of caveats because NTLM and Kerberos is not supported well on non-Windows boxes. So you really have to use HTTPS with basic auth. And there's some steps here. Again, you can download the gist to see how to set that up. But I'm going to just skip over that one. I'm going to show this real quick, which is, if you're not aware, we do publish a bunch of Docker images. And I can run it from here. So because I already have this downloaded, it's really fast. But if I do base version table, cat, etc., LSB release, this is running on Ubuntu 16.04. And again, it already includes PowerShell Core 6.1 in this case. And I'm going to skip the one for Alpine, but this is just to mention if you're a Docker fan, you're probably using Alpine for your Linux distro, and we support that as well. All right. If you are writing scripts that target Windows, Linux, and Mac, then you should be aware of these automatic variables. Is Windows, is Linux, is Mac OS. This is very simple. I'll run it here. Hold on, didn't cut it. Don't do that. There we go. All right, very simple. If you want to write the same script that works on Windows PowerShell, PowerShell Core 6 on Windows, and Linux and Mac, you have to be aware that is Windows doesn't exist in Windows PowerShell. All right, so it's never going to return true on Windows PowerShell. It is going to return null because it's not defined, unless you defined it yourself, in which case, don't use these names. Yeah, we should have had a better solution for namespaces, but it is what it is today. But you just check to see if it's null or true, then it means it's running on Windows. And then you can do the PS Edition check to see if you're running Windows PowerShell or PowerShell Core. I'm going to skip this, but this is just showing that for case sensitivity, the Mac OS is file system, not case sensitive. On Linux, you can have a case insensitive file system, but by default it is case sensitive. So just to be aware of the differences. If you're a module author, what this is showing is that the way PowerShell, including Windows PowerShell, imports modules is based off of the module folder name, not off of the manifest name. And for historical reasons, we're not going to change that. Or for compatibility reasons, we're not going to change that. But those two have to match. So what happens is that if you have a name called test module capital T capital M for the folder, and your manifest is all lowercase, then guess what? On Windows and Mac, that works perfectly fine because the file system doesn't care. On Linux, it won't find that file and it'll fail. So just be aware that you have to have these two things match. The other thing to bring up here is, and this also applies to Mac OS, is that environmental variables, and actually everything on Linux is case sensitive. So if you type env path, guess what? That's not going to exist. It has to be all caps. So in general, my recommendation is just rely on tab complete, because we'll figure out what the right thing is, and you just save that to your script. Another thing to be aware of is path separator. So if I quickly show this one. So path separator is not the same as like a directory separator. So if you have like a path here, which is like the PS module path or just env path, it separates the different sections of the path with a colon on Mac OS and Linux, and it's a semicolon on Windows. So the way to do that is you can use, and there's an issue open to kind of make this a little bit easier for PowerShell scripters, but the idea here is really to leverage the .NET path separator. So here I'm just showing, I want to add this custom path, so I'm going to use the PowerShell split. So I'm going to split it from a string into an array. I'm going to add my thing to the end of it, and then I'm going to combine it back, and I'm going to use the path separator as the delimiter. It's also important to know that the temp folder is completely different on Windows, which is TEMP, caps. Actually, Windows doesn't matter. Linux is TMP, all uppercase, and on Mac it's TMP dir, all uppercase. So the recommendation right now, again, we have an open issue to kind of make this easier for scripters, is you can use the .NET API. This will give you the right information. So if I show this on my MacBook, see. So it points to the same place. All right, towards the end, I want to show this one in the terminal app because it shows up better. So we had improvements to escaping the escape character. So a backtick E is escape. This means that you can have the horrible blinking text back, that used to exist a lot in the 80s or something. You also get colors and stuff like that. And the other thing, and this won't work in Windows because they don't have the emoji characters yet, which is if you want to output Unicode characters, there's a nicer syntax now. And this was contributed by the community, so you can have all these nice emojis. This works well on Linux and Mac, but again, Windows currently doesn't have the emoji characters, and Windows doesn't support the blink, which may be a good thing for now, but it does have the colors. All right, let me just finish this up real quick. I think we're running out of time. Use SSH remoting, WSMan's the past. And just for FYI, as I say that, I was one of the original engineers on the team that created WSMan and WinRM. But I've already put that aside. Use SSH. Be aware of the OS differences. I linked to a couple of discussions regarding abstractions so that it makes it easier to write these scripts on PowerShell versus knowing a lot of .NET APIs. So if you have ideas on how to do that, then participate in a couple of these. This is not all the discussions that's happening. So this is kind of like my last slide. So let me just finish it real quick. Some future stuff that we're looking at for 6.2 timeframe. This is not an exhaustive list. First one is error message format improvements. So I kind of want to just show this real quick. This is a different gist. Again, you could download this today, try it out. Go here, file, new. This one I actually want to save. Update error PS1. All right, so what this is, actually I'll show it this way first. So if you have an error on the console, a lot of people don't like a huge amount of red text, and some people don't understand, like, why do I care about these other details? I just want something that tells me it failed. So we're exploring different ways to represent error messages, and this is just one example. So instead of having like a huge block of red text, though, I just have a single line. So these two are the same error, and this is what it's represented as. And I have some other examples here where, in this case, and the coloring is a choice I made, and maybe it could be improved. In this case, like, no such param, it doesn't exist for get item. So it actually shows the param that doesn't exist in purple. This may not be the best example. If I had more params, it would show up better. In this case, it says the unexpected token, the closing parentheses, it shouldn't be there. And I kind of show that in a different color. So now that we can leverage VT100, we could actually, and I'm not suggesting that the way I have it here is the best way, but it shows that there's an opportunity for us to improve the rendering of error messages. And again, there is an open issue on that to discuss. So if you guys had ideas, do participate. Whoops. Obviously, as we look into the cloud, Jeffrey talked about programming at large, how to do stuff asynchronous. Thread job is great for some things, but it's not the final solution to everything. So we are looking at making some language improvements in PowerShell to make asynchronous operations easier. We have some work happening for foreign input tracking. Basically, this is like the last column in one of Lee Holmes' blog posts in terms of security. So from PowerShell script perspective, like, we're one of the most secure scripting languages in terms of both tracing everything that happens, and also just, we've done a lot of work, like Jeffrey likes to say, we have fire in the belly for security, so we've done a lot of improvements in security. What this last part is that if you have a module or a script that takes input from a user, then that is by definition foreign, because you don't know what that is. So we're going to have a way, or working on a way, so that we can actually track that and actually require additional validation in some modes, like constrained language mode, so that if you have not explicitly said, I validated that this is safe to use, we will error out, right? So it actually protects some people from having like script injection and issues like that. We already have a PR that I linked to for implicit remoting perf improvements. So again, you saw that I created a connection to Office 365. So if I do like get mailbox and I want to do some sorting, some grouping, whatever, what happens today is that for each part of the pipeline, I get all the results from the cloud downloaded to my machine. I process something, and I send it all the way back up, and it comes back and forth, right? It's a lot of network traffic. The idea here is that we can analyze the entire pipeline and say, hey, these commandlets are actually all on the target side. So we can just send the entire pipeline up to the cloud and have it processed entirely there. So one of the other benefits is live objects actually work, because in the case where things go back and forth from your machine to the cloud, when they get serialized and deserialized, they're no longer live, meaning you can't call methods on it. Yes, we are working on PowerShell Core 6 in Azure Functions 2.0. I don't have any announcement beyond that, like in terms of a timeline. We are working towards a 2.0 release of editor services and VS Code PowerShell. The big thing is really PS Readline that you saw that I was using, because I have that alpha release on my box. I showed like the markdown rendering for any arbitrary file. We want to be able to leverage that for all the help content to make it easier to read. And again, we'll work with some of the designers at Microsoft to figure out what the right way to show that in the console for the colors and stuff. And one of the big things that my team was working on in the 6.2 timeframe is not features, even though I showed some feature stuff. It's really, we actually incur a pretty substantial manual process when we do a release. So even with the 6.2 preview 1 that came out today, that was like almost 2 business days with a couple of engineers, because we have to run all these tests across all distros that we don't run on a regular basis. We have to analyze the results. We have to package stuff, build stuff, get it signed. So we're spending a lot of time automating this, and our idea is we want to leverage Azure Functions. We want to leverage Azure DevOps pipelines, and we're going to do all this, and then we're going to blog about it. We're going to release all the tooling that we built as open source, so that hopefully other people can leverage it as well. Again, I have no timeline on when that's going to happen. It's in progress, and it's not a small effort. So to summarize, start using PowerShell Core 6 if you haven't already. There's improvements is the main reason to use it, and yes, continue to use Windows PowerShell. We will support it. But if you want the improvements, you're going to have to start using PowerShell Core 6. You can safely use it side by side. Be aware that there are differences in PowerShell Core 6 that we've made explicitly. We think it gives it a better platform. Also, if you're doing cross-platform stuff, be aware of the OS differences. And if you participate in the community, that helps everyone. So, and participation here doesn't mean you have to submit a pull request with code. If you just go in a discussion on an issue, provide your opinion, that's value already, right? Because if you just hear from the same 4 or 5 people, then we're building a PowerShell for those 4 or 5 people. And I want to build a PowerShell for everyone. Whew. All right. I don't know if we have time. We're in the break period, I think, technically. But I'm available, so if you see me, just come up and ask me questions. I'm more than happy to answer anything, almost anything. Yes, and don't forget this stuff, important stuff. Whew. All right, I think I'm done.